Okay, today I'd like to teach you guys about how switches and capacitors can change things about our circuit. Now, we're probably not going to get to the capacitor part today because I don't want to overload you. It'd be different if I was teaching you face to face because I could see that you understood the first part before I moved on to the second. But I'd like to break this up into 2 different days. And today we're going to focus simply on the switches. Okay, so what we have is a circuit that has a battery, a current meter, resistor 1 and resistor 2, and then a switch. This switch, you'll notice, starts out open, which means that no electricity can flow through this bottom path. So, in this configuration, hopefully you can see that you're going to have current come out of the battery, go through the meter and get counted, flow through R1, flow through R2, and go back to the battery. Nothing will flow through this bottom path because of the open switch. So it's simply a series circuit. You guys should have no problem with a circuit like this. So what we do is we do I total equals V total over R total. We use Ohm's law. We read our value. Notice the highest value is 40, so that would be 4, 8, 12, 16. We're a little beyond 16. We're not quite at 18, so maybe 17. We put that in as our current. Our voltage, we use the voltage of our battery because we're doing total voltage. And we solve for total resistance. When you get your total resistance, it does not tell you what R1 or R2 is. It tells you the total of those two. So it's helpful, but not perfectly helpful. So then what we have to do is throw this switch. When we throw the switch, something really unusual is going to happen, and I want to make sure you understand it. So now I throw the switch. I've created a path of no resistance. There is no resistor on this path. So we know that current tends to take the path of least resistance. This is no resistance. So that means all 100% of the current will take this bottom path. And it will look something like that. So when we threw the switch, we went from around 17 for our current all the way up to almost 28. The reason is we bypass this resistor. We create a path of no resistance, and that in essence short circuits this other path. This other path gets no current. Okay, no current is going to pass through that top one because it has a chance to go through a path with no resistance. This is called a short circuit. So now it's real easy. We can do I equals V over R. The I is our value here, which is around 28, a little less. Our voltage we're going to use is 1.5 because this resistor gets the entire voltage. There are no other active resistors. And then we solve, and when we get the resistance, we're getting the resistance of just this one. R2 has been effectively taken out of the equation. We solve it for R1, and then we go back to the one that we had earlier, and we plug that R1 in, and we can figure out R2. So I hope you guys understand the purpose of the switch. We can have the switch open, in which case all the current takes the top path, and we have a simple series circuit. Or we can close the switch, and now all the current takes the bottom path, and we've shorted out the top path, and we've created a simple circuit with just one resistor. So I'm going to have you guys work through the details, first of this one, and then second one on your own. And I'd like to make sure that you master this, and then our next lesson I'll tell you how things change if we put a capacitor into our circuit. But I think this will be enough for today.